But anyway, Matt, how's it going?
I'm well, thank you, Seve. How about you?
I'm good. We should explain our circumstances.
Indeed, please. You go ahead. You're the one that's unfortunately changed a little more than intended.
Right. I don't know how much I should say right now, but suffice to say, our podcast studio was there's no equipment in it anymore, and
I think it's public information if they've kicked everyone all out of a co-working space, right?
I think by time this comes out, that will be public information.
And even if it's not, everyone knows the companies are gone.
Everybody knows
that's not a secret.
The companies aren't going to be there. Yeah. So, basically this co-working space with 200 startups in it.
What was it called? Come on, like it's already public.
It's called Solaris. So Solaris SF, really great co-working space, really great community, but all of a sudden, out of money. No more money. Cannot pay. And so
easy come, easy go in the city.
Easy come, easy go. That's it. I mean, every company is now going to find new offices. They are trying to get people set up with new places. I am one of the displaced companies myself, so I'll be looking around. I did get a small like rental lab, so I still have that space to work out of.
Rental lab.
Yeah, it's like I don't know. It's
like a hardware lab.
It's like a shared lab space, but I rented a shelf, and so I can put stuff there.
How much does a shelf go for in San Francisco?
A lot. I mean, like literally like $350 plus lab privileges.
I should sell more shelves. That's a good deal.
If you have a lab, like what are all these hardware? There's all these hardware companies popping up in San Francisco. Literally, what do you do if you don't have a space to solder and do whatever? I barely need to solder too. I solder like once every 2 weeks, but when I need it,
You spend a lot more time debugging a board, right, than necessarily soldering or anything. But you still need to have somewhere you can set all your stuff out.
Yeah.
And there's like just a million little pieces of equipment that are nice on aggregate. So
yeah, and all those people out there who say, "Hey, just go on your sidewalk with a soldering iron and do your quick little soldering."
Who says that?
Everybody in the comments, I see it all the time. To all those people, having the right equipment matters. I actually found this out recently because I bought kind of like a smattering of different things. I bought a hot plate. That was mostly a wireless soldering iron. Never tried one of those before.
Yeah, which one?
I can't remember price of.
Okay, was it a heat battery or battery?
It was.
The old school ones used to plug in. They just got nice and hot. And then they stayed hot for a little while. Was kind of how they used to work. But
yeah, there's also gas. I found out when looking for soldering irons. I had no idea there were gas soldering irons that you could, you put like a canister in. I think, butane. Yeah. But anyway, I got this kind of smattering of equipment, and then I go to this rental lab, and they had like a hot air gun, and that was infinitely better for the task I was doing because it was like a partially assembled board. So like putting a partially assembled board on a hot plate.
Why were you assembling the board?
So we just started building like little custom keyboards, and I wanted to use the RP2350. I wanted to make, this is like one of the first custom keyboards to use a RP2350.
Yep, cool.
But nobody will assemble that for you because they don't have the chips in stock.
The 2350 you can only get as part of the, they're calling it the Pico 2, or what are they calling the breakout board?
Exactly. You can only get it as part of the Pico 2, and you can also, I requested samples from Raspberry Pi, and they generously sent a big sample pack.
That's so
I
cool.
would definitely do that.
That's awesome.
Yeah, unfortunately, they are, they're a little small. So if you're, if you're new to soldering, it might not be the best thing. But of course, I'm not. I'm a great solderer, the best. Do you think Trumpisms?
We're going to be hearing a bit of that for the next 4 years, hey? So for everyone's context, we're recording this on the 6th of November, the day after the election results have come out. And to no one's, I would say, surprise, I think this was, like, at best, this was always a razor-thin election. And so I don't think anyone's really surprised by a result one way or the other. Yeah. But in San Francisco, there's an 80-something% sentiment that this was sub-ideal. Now, I don't get to vote, so I won't relinquish my sentiment. But it's It's not the most joyous day here in terms of atmosphere.
Not the most joyous day. Not the most joyous day. I think, on X, on Twitter, people were, it was very like right leaning. There was like a lot of Trump stuff. But on the streets of San Francisco, it's a different kind of sentiment. Yeah. A lot of people upset.
When was the latest you're out last night?
Like late? How late did I stay up? Or
well, I was cycling home at about 8:30 from the office, and it was like there was a watch party in the middle of Valencia Street.
Right.
Valencia Street in the middle of the Mission here, big lively street. They closed off the center of the road and had a big inflatable screen, and a whole bunch of people watching, and no one looked real happy. So
yeah. I read, don't go to a watch party, unless you're really sure you're going to win, because it's like a sad party together.
Have you ever seen the stats on sports that suggest that that sports on net makes you feel bad because you feel much worse when your team loses than when they win, and statistically that's something like half over the lifetime of a team.
Yeah. I mean, that makes sense to me, but at the same time, you want to feel something, right? You can't just be numb. I scroll on Twitter for so long, I'm like, I don't feel like anything right now.
Yeah.
Or not Twitter, TikTok. Friggin' TikTok.
Oh my God,
does
that is dangerous.
Yeah, TikTok is such a rabbit hole.
The dopamine overhead, yeah.
Oh, yeah. But, wow.
Okay, so you're the best solderer and you have a lab space. That's sorry. That's why we had a bit of a divergence there, folks.
Right, and I was building a custom keyboard, and the one thing I needed to solder was the Pico 2. So like I have like everything else comes soldered.
Yep. So you just needed to reflow that one component.
That's
Makes
right.
Sense. Yep.
And this was also my first time working with the Pico 2.
Okay.
And
how's the software?
It's delightful.
Wonderful.
Yeah, I used MicroPython also for the first time. I'm like,
oh really?
I'm like, the last microcontroller I used like really extensively was Cypress PSOC.
Oh yeah, I love those.
I love them, right? But I wanted to get with the times, so moved to the Raspberry Pi camp. Something I was wondering working with that, I was like, this is fantastic. How much different is that experience from the RP2040? I don't know if you've used the Pico 2 yet, but I basically dragged over my bootloader, I think, for MicroPython.
Cool.
And then I just kind of opened up some IDE and was able to load Python. It was just incredible. It was trivial.
It's insane. It's so impressive how much effort has gone into making microcontrollers accessible, and huge credit to Arduino. People shit on it. I was a firmware dev at Tesla for 2 years, and people are like, oh, you couldn't do this in XYZ in Arduino. It's an underutilized tool, really. Like, sure, you wouldn't necessarily put it in a lot of production products, but by God, does it not mean that you can build your own test equipment? That's incredible.
Yeah.
Like, that is so potent.
Yeah.
And then MicroPython's a blink further. I worked for a company, I've mentioned this before, but back home in Australia, Planet Innovation, who shipped products that had MicroPython embedded in it in order to do OpenMV. It meant that they could ship those, and they certified those as I can't remember which class precisely it was, but under the therapeutic goods back home is what it's called in Australia. And these were for sample analysis, basically, not something that you would embed in yourself, but you can do incredible potent stuff with it.
It's so powerful, and the fact is, Python and JavaScript, these languages are much easier to build things quickly in, and then when you can ship that to your production prototype, that just makes everything so much easier. Something that's happening in the JavaScript world right now is you can take a subset of JavaScript and get C-like speeds as long as you use the JavaScript in a particular way. So for a lot of people, that's a better alternative than writing C code, right?
That's just with a just-in-time compiler. You bytecode or something, or is it to WASM? Or what do you do?
So the project to call out here is Profer.
Okay.
And what Profer does is they build JavaScript into WebAssembly directly. And so if you look at, this is like very TypeScripty, but if you look at the Dino world or the Node world or whatever, their binaries are always 100 megabytes because they bundle this huge runtime in there. Never going to run on a micro.
Yep.
Profer is different. Profer takes that JavaScript code and it basically turns it into C code, and then it compiles it, and it's all done with this kind of transparent stuff. So their output binaries are only 20 kilobytes. They're extremely small. And right now they go to WebAssembly, but I think it's only a matter of time until we have a WebAssembly runtime.
Go to assembly.
Right, just go to assembly.
WebAssembly, that's an interesting one. Could you build a instruction set? I mean, WebAssembly is an instruction set, right?
Right.
Could you build a CPU that ran WASM directly?
I don't see why you couldn't. I don't know if WASM has any like novel feature that would prevent you from doing it, but I think that problem with that is like people optimize the hell out of that assembly. Like there's particular assembly code for some of these CPUs that come out and features you have to optimize for and stuff like that. And WASM is really like a way of running assembly anywhere. It's not optimizing.
It's a shim for everything rather than a optimized assembly instruction set. Yeah.
Exactly. And also like browsers, they have this huge machine designed to run this super quick. You know, they're willing to bundle gigabytes of like optimizations in there.
Yeah.
Microcontrollers aren't going to have that.
No.
So,
no. That's an interesting one, actually. I wonder what size, like hardware analog gigabyte size you have equivalent bundled into a CPU. If you were to encode all of the instructions that a CPU does like simultaneously, what size is that? Are we talking, kilobytes, megabytes? Excluding like removing the RAM because it doesn't count. But if you just like the CPU itself, if you were to write that in the most optimized way, it's probably on the at least kilobyte scale.
I think so.
To encode all of those instructions, it's pretty cool.
I think so. Yeah, crazy. Hopefully we see more higher level languages on microcontrollers though.
So
Speeds
you
up
got the
everything.
keyboard up and running then?
Yeah, we got the keyboard running. And then as soon as I got it running, I was like, all right, onto the next thing, right? Because, it's not like particularly interesting yet, I would say.
Yep.
Something that would make TS Circuit custom keyboards interesting is if you were able to like move the keys really easy. Like if you could create your own layout.
The up and down should be easy. You're pressing them a lot. So if it's not, you got a problem.
Right. Yeah. There's got to be something. I really like people are... something I think both Autopile and TS Circuit enable is like, have you seen this talk about car panels and how, they're all touch screens, but maybe mechanical design will come back?
Yeah, okay.
I wonder how much of that is just like making a new UI is very cheap in software, but very expensive in hardware. If you can kind of like take your design, automatically convert it to code, convert that code to a PCB so that the mechanical design from at least an R&D perspective is no extra cost.
Yep.
Maybe you have something there because people are willing to pay for the upsell for mechanical buttons on a car, right?
I think the other thing, like the other obvious thing that you can do in software that you can't have or in hardware is mutable designs both on the short and long time scale. You can have multiple panels you swipe through, right? Or a settings menu open, right? So the keys are hidden.
Yeah.
Now you wouldn't have a big flap that you could chunk open right on your car to access a bunch of additional buttons. But
people are talking about programmable buttons, like buttons that maybe change purpose depending on what you're doing, but that's a slippery slope.
How much have you liked them is the question.
Like how much do I like buttons on a car?
So I remember driving a mate's dad's BMW back home briefly, and its cruise control was just abhorrent to use because it had an up, down, and center button with a switch to flick it on or something like that, and then it had two D-dents on the up and down. So if you pressed it softly and if you pressed it hard, it would ka-chunk a second time.
Ooh.
And I just wanted the cruise control to turn on,
Right.
So on button and then set. And then I accidentally pressed it too hard and then it clicked up 10 Ks an hour. And then all of a sudden they started accelerating. I was, what the hell? Anyway, so there's a huge trade-off between something that is intuitive despite not changing its physical or tactile appearance, right? Because you're setting those things in stone, right? With a physical button. But then on the other hand, that button's always where you want it to, or always in the same place. You can feel it. You can feel when it clicks, and there's an enormous upside to that.
Yeah.
Right?
So having customizable buttons is kind of like destroying the upside of the physical button to a large extent. I can see that. At the same time, there are things I feel like will never change. Volume adjustment. Yeah. I just feel like that there should always be enough.
Absolutely.
For that,
Totally agree. I think Tesla's done a really good job with this. How much
do they have a top? I've barely ridden in Teslas. So,
oh my God. We should go for a spin.
So there's a dial.
So on the Tesla steering wheel in the 3NY and the S and X, I've driven much less than much older ones, so I can't comment as much. They had more going on. But you've got two stalks that each go up, down, and in, and there's buttons on the end. And then there's two thumb scroll wheels that go up and down. They scroll. And then you can click in and out and forward. Right?
Really? On the scroll wheels?
Just like your mouse, your middle mouse button, right?
Oh,
you can
really?
scroll and you can click in, and they also go sideways.
Yeah.
And so they subtly change function depending on what high level driving mode you're in, but they're generally the same thing. And then in the sense that the right one is your cruise control speed as you scroll it, and you scroll it up and down. And if you're not in cruise control, that scroll does nothing. And then if you're in autopilot, let's say cruise control, it's now all autopilot. If you have autopilot, there's no distinction between cruise control and not. But if you click it left and right, it'll change the aggressiveness of it from like passive to aggressive, to casual. And so I think they've done a great job with that, because there's these two dials that are within reach. They're tactile. You can feel them. You can press them. And the only thing I would complain about that wheel is that the horn sucks, because if you press one side of the horn, it doesn't depress. You have to press like the full center.
Oh, I see.
It's a very aggressive move if you just want to beep someone. Like,
they're trying to reduce road rage. You have to actually be enraged to give a honk, I guess.
I wish, but I think the problem that it poses is if you beep at someone later, if you beep at someone as they're doing something wrong, they're like, oh, thank you. Sorry, I didn't, whatever, I realized. But if you beep at them 2 seconds later because you were trying to press it and it didn't work and you pressed it and you're like, now I look like a dick at just beeping them afterwards,
Right. It's more of an angry, like, hey, you suck, rather than don't do that. Right?
Yeah, like, oops, look out. No, I was just going for the oops, look out. I'm so sorry.
That's true. There's really two types of honks. There's there's probably three types of honks. There's cautionary warning. There's you're an asshole, like F you. And then there's also that double tap.
What's up, man?
That what's up? Like,
what's
hey,
happening?
Thanks. Like, oh, you can go. That.
I wish I could
nice
double
one.
tap. It doesn't seem to work.
Really, you can't double tap.
It just I hate the horn button. Maybe it's just the tolerances, because they known for a little loose tolerances, but I can't get it to bang quick.
Can't get that double tap.
No, I wish I could. But we should go for a spin sometime. It's bloody fun.
Yeah, absolutely. I'd love it.
So instead of being at Solaris AI, which is was your co-working space up until, what was it, yesterday that it went under?
So they're not. I think you can actually stay in the space until January 1st. And
it's just the podcast equipment went left.
The podcast equipment left, and I'm guessing people are going to kind of bolt, because it's like, do you really want to set up on a place that's not going to be around? It's like, you get too attached, right? It's like it's like visiting your ex-girlfriend right after breaking up. It's too soon.
It's like got to give it time. Out of a parent's house or something.
Right.
Don't do that. That's weird. Don't be weird. So instead today we are at Adapal HQ. So thank you very much for coming over. Instead, we've set up here on a barrel in one of the few rooms that we actually have here. It's adjacent to our break room. It was set up as a bar when we moved in, but I much prefer it as the podcast studio. So I think I'm going to keep it in this format.
It's really cool. You should say a little bit about this building too, because this building is crazy.
This building's a bit wild. We're in one of the few brick buildings in San Francisco. There's not many. It's been, reinforced with a heck of a lot of steel to make it earthquake resistant enough to meet spec. It's in Soma, so just north of the freeway, right near Costco. And it's an old brewery. It was built, I think, finished 2 years before Prohibition.
Wow.
So never really got much used for it.
Yeah.
And if you can see in the background up here, all of these louvers is where a whole bunch of, I believe, exhaust pipes went through back in the day. And so they went out here across the room and then up the other side, if I recall correctly. And you can see around the building, there's a whole bunch of like sort of old industrially type piping sort of left as a part of the aesthetic. And I love it. I think it's so cool.
Super, super cool. Yeah, like definitely it's got that kind of like, let's build, like this is where like stuff happens kind of
let's build something,
vibe. Yeah. I don't know why breweries have that vibe. I guess it's also like a little bit casual. What's like the ultimate like hardcore like people build here vibe, you know what I mean? Because I imagine like this kind of factory builder aesthetic, and it's kind of like concrete floor factory, and then like this super drafty room, and then a big American flag on the wall or whatever. That's what people are selling as like the factory like builder thing.
But big tin can, I mean, it's true. If you are serious building large scale hardware and proper manufacturing, you are building a millimeter thick steel can with a big old concrete floor and maybe multiple levels. And you're going for it because all you're going for is floor space and volume, basically. Right. And it needs to just be big because you want everything to be self-contained.
Yeah. I think a lot of people... Have you ever played Factorio?
No, by the way? I haven't, but it looks so fun. I've got such an addictive personality. I can't do that type of stuff. I got to be careful.
Yeah. So here's my... it's almost like hierarchy of needs. How I justify video games. Elon Musk recently went on Joe Rogan and he said... he was a top 20 Diablo player.
Yeah, crazy.
In the top 20s. And he was like, yeah, I think it keeps your brain alert, and it like helps you know about your mental acuity and stuff like that.
Yep.
And I feel like there's some truth to this. So like what I do, I have this like hierarchy of like productive things almost. And obviously like working on startup, like crushing code, whatever, getting in that focus zone, that's like the ideal. But when it's hard to stay in that, what do you fall out of and what do you go to, right? So if you're in TikTok land, you're in the ultimate like super consumption state. If you're like on Twitter, but you're tweeting, at least you're making something, you're engaging your brain a little bit.
Yeah.
And then I wonder if video games are kind of higher than that, factorial, because you kind of, something I've noticed about myself is I get really addicted and obsessed with a video game for like 3 or 4 days.
Okay, yeah, right. The short scale, but like
very short scale.
Very deep. How deep?
Like I'll try to beat a game, and I usually get like 3/4 of the way through a game, but I feel like once I understand the mechanics of a game, it kind of falls off for me, weirdly enough. And then I want to, like, sometimes I even want to play a different thing.
You've just made, like, you've taken the fun bit, you've learned it,
right?
You clearly enjoy learning,
right? I know what to expect and all of this, but when I play those video games, what kind of reminds me is like how long am I willing to stare at my computer, be hunched, all of this? Because I find when I'm working on something I don't want to work on, my back starts to get sore. It's like, oh, I should get up. I should take a walk.
You can see it in people. You can see visibly in people when they don't want to be there. That's why, stand up straight with your shoulders back is actually a pretty bloody good piece of advice.
Yeah.
Because you're telling yourself is like, hey, you better want to do this. Figure out how to want to do it,
Yeah, absolutely. So anyway, I started playing Factorio, but long story short, but I think a lot of people, I get in Factorio, you basically are setting up a factory line.
Makes sense.
It's like the whole game.
Okay. Yep.
And I get why people like want to get a space that enables them to do that. They think like, I'm going to automate everything, like Elon Musk originally with Tesla, where he was like, automate everything. So I think people get big warehouses and they just want to set up lines of machines in them. That's like what's going through their head. And you can't really do that in comfortable, non-tin cans, I guess.
Yeah, you can, but it's a hell of a lot harder, like, if for argument's sake you wanted a big brick building in the city to do that, well, that land is going to be insanely expensive, right? Yeah. And so what, you're going to build a high-rise factory? Like, maybe you want, but do you want to build a high-rise in the city just to use that floor space for factory? It's just a competition problem, You're going to be out-competed by people wanting to live there, obviously. Yeah.
I don't know if... I think this is a pretty unusual cap, but I want to say it's Adafruit has New York, like a New York factory thing.
Yep.
Yeah. And that's like very abnormal. It's very strange. Most people don't do that. They don't choose to build in cities.
Sense. They've got a pretty small factory. They're doing high variety, high mix, medium complexity in the scheme of things, but, very high mental work. High level of mental work with a little bit of manufacturing and high mix of manufacturing, which is why it makes sense to do in New York, because what, are you going to split your factory from your engineers, and then your engineers need to commute out of the city in order to go there a couple of days a week and blah, blah, blah.
Right.
It just gets hard.
It's one of the interesting thing about that, though, is it's one of the few places where we were talking about this a couple episodes ago. In China, a lot of times the designers are so close to where the thing is being built that you have this really tight feedback loop.
Yes.
So Adafruit kind of has a way of doing that.
Absolutely.
And I don't know if you felt this, but like I feel like there's competition between Adafruit and SparkFun.
A little bit, yeah, of course.
Yeah.
They sell the same things.
Right. I don't know how SparkFun operates exactly, if they have a similar system or not.
They do, yeah.
So they do kind of build...
in-house manufacturing, yeah.
Oh, I didn't know
Boulder,
that.
Colorado, yep.
Oh, interesting.
Yeah. So they're in a much less dense city than New York, of course, but they're still in a city.
Yeah.
And
Boulder is really great too, because Boulder is right next to Denver. Yeah. So if you have access to Denver, like you kind of get the best of both worlds. Because have you been to Boulder?
No, I wish. I've heard good things
freaking
about
beautiful.
It. Yeah.
I love Boulder. The thing about Boulder, Colorado is like you'll go somewhere shopping and like cashiers and stuff, they'll be like, oh yeah, how you doing today? And like, oh, you see the weather, you going out to this hike, you hear like the skiing's good, and you're like, whoa, all right.
Everyone's there for it.
Incredibly nice. Yeah, it's a great time.
Yeah. I like nice people. I'll have to give it a crack. Yeah.
But a lot of herbal teas are made in Boulder, Colorado.
A
little fact.
They're a fairly crunchy bunch from what I've seen. Between this is a compliment depending on who you ask. Granted,
what does crunchy mean?
Well, they're like like almond mums kind of vibes, right? Like they want to go out for a hike and feed their kids organic food and like non-GMO almonds.
The way I think about the personality of Boulder is you have kind of like very techy because there's like AWS and stuff in there. Like
AWS has like an engineering or a data warehouse.
I believe they have engineering in Boulder, Google. So my brother works for AWS in Boulder.
Okay,
and the way they operate their offices is so much different inside of Boulder.
Oh, okay.
He was on a committee at AWS and he was enraged. He was like, we are not able to hire because Google has a climbing gym in their office and we don't. And he was enraged about this. It's like, we're in Boulder. You have to have this.
You're in the wrong city to be fucking around.
Right. But that's just the culture. And they also have like, you can bring your dogs to work. Like everybody is bringing their dogs and has them in the gates and stuff like that. It's just the vibe.
Badge, their little tag or something?
That's a fun idea
for the dogs, that is. But
you badge in your dog, like they have a little RFID employee badge on their tag.
I think I saw a Google tag on a dog here in San Francisco.
So
I was wondering, was it an official one or did someone they were a fan of Google's work?
That's super interesting. That's super interesting.
So you've been to Boulder a few times then, if your brother lives there?
Been to Boulder a few times, liked it each time. I would definitely go to Boulder. It seems like it's got that good intersection. I feel like I'm not outdoorsy enough.
Yeah.
I'm techie enough, but not outdoorsy enough for Boulder.
not quite crunchy enough.
Yeah. I'd still give it a try.
Yeah. I'd love
the proximity to Denver is pretty cool too.
It's high as well, isn't it?
It's very high.
High altitude.
It's very high.
Yeah. How high? It's a mile high city is what they call Denver, right?
Oh yeah.
What's a mile in feet? It's like 5,006.
Was this a quiz? What is? I'm just Americans knowing units. This is. I think it's like 3,000. Is that right?
No. That's feet to kilometers, roughly speaking. It's like 3 foot to roughly 3 foot to a yard, roughly a yard to a meter. It's not quite right. So 3,000 feet to a kilometer, and then it's 1,600 meters to a mile, which means that it's about something in the like 5,000. I think I want to say 5,800 range for feet. So that's a lot of feet. That's a decent altitude,
Oh yeah, for sure. I also went skiing in Boulder, and I feel like we were going up because you're going up from Boulder. It was like
you got the oxygen mask on.
Yeah, exactly. It's like you feel lightheaded at the top, and you just ski until you feel a little better.
And it wasn't just the alcohol. Last weekend we were out in Yosemite, and we hiked up from the valley to the top of Clouds Rest as our like day up, and that was 6,000 feet of climbing. We ended up at Clouds Rest is just shy of 10,000 feet. I think it's like 9,870 something, right? Like it's just shy of it. But you're really on top of the world there. It's gorgeous. You can see out to the Central Valley. You got one heck of a sunset and sunrise for that matter. But boy, I don't normally get altitude sick, but you climb 6,000 feet, do a bunch of exercise. It's kind of cold. You're like, I'm a little like woozy. No, just a tiny little bit. Just a tiny little bit.
We should go down.
But you imagine if you already start up there in Boulder and you're hiking, you could pretty easily get up to those kind of altitudes.
Absolutely. The nice thing is if you ever go to a conference, you're gonna, the higher amount of oxygen, you're gonna be like on point, you're like, I trained to use my brain in low oxygen. Like, let's go.
What, the conference, all the CO2 everyone's exhaling. It's
Oh yeah. That's, never thought about that. I've been very cautious of CO2. I don't know if I already talked about this, but
no.
I go to a hot yoga studio.
Okay.
Sometimes. And I've been thinking about all of these really tight people breathing in and out and how that like the air in the room stays like super hot. I'm feeling like it's a little stale. I'm like, the CO2 levels in that room, they must be insane. And I bet nobody's measuring it.
Yeah, I've got a meter upstairs if you want to take it in one day and tell us.
I wouldn't mind. What kind of meter do you? So here's the thing. Equinox, very strict on recording. And so what I really need is like an IoT CO2 sensor that I can kind of like tuck away. So it's not like
it doesn't look like a camera.
And I would love to publish that because I cannot find anything on this. And Equinox, extremely nice facilities, right? But when I'm in that room, I'm like, there's no way. You can't keep like this hot of a room and have great circulation and have this many people. Like,
I mean, you could have a nice counterflow heat exchanger. You could like do some things. Is it humid as well?
It feels humid when you're as sweaty as I get in hot yoga, but not sure.
Okay, nice.
Not sure. Probably.
Interesting. Yeah, because it makes a big difference as to how your sweat evaporates as well, of course, right? So like the wet bulb temperature is what gets you. If you got like a 35 degree wet bulb temperature, you might cark it. But if you're lower than that, or if it's dry, like back home, it would sometimes get to, I guess I'll have to do the conversions, but there were summers that it would get, I think the hottest I've ever been in was 48 degrees Celsius, which is 120 something. And it's, not infrequent that it's above 100, but it's dry. It's like being in a hairdryer. I don't mind it at all. Like you can go for a run or a ride in 37 degrees if it's dry, because then you sweat and you go through a lot of water, you got to be drinking. And you obviously don't want to overheat. You got to be a little careful with yourself. But if it's wet or humid and you do that, you're in serious trouble. You got to be careful.
Yeah, absolutely. Yeah, dry heat definitely better. I think we have sort of it's like dry in San Francisco, right?
Yeah. San Francisco, thankfully, is
easy.
Well, it's microclimately. So where we are in the city, it's nice and dry and generally not too bad and whatnot. The water's falling out of the area in the marina, like where it's foggy.
That's right. That's right.
It doesn't even.
Where Carl hits.
Carl's the fog.
Yeah, Carl's the fog of San Francisco.
Yeah.
All right, let's jump over here to let's see what we got. I wonder. I'm curious your take on this YouTube actuator guy. Have you seen this?
I haven't seen it. Explain it to me.
Okay, so this guy, let's pull up his video here.
So this I see the king of YouTube actuators is now making his own is the title you've put on this bit.
Yeah, and I guess the company and his brand generally is Scientific, and he just reviews actuators, but he decided to create his own actuators.
Because of the three main reasons. First of all, many companies, they don't provide any manual or any example of the program how to control.
So I guess he's improving how easy it is to program in addition to just making like a really quality actuator. I'm really curious your take on this. I also have a little bit of stuff on his pricing. Let's jump around.
Using Arduino. This a board from Logan. You can buy it from the Seed Studio website. It's called.
So how much have you worked with actuators? Have you worked with actuators?
A bit over the years.
Yeah.
We built our own, the spin servo drives as well, which are an open source design. They're without a gearbox. They're a NEMA 17 brushless motor with an integrated driver on them. And they're they're for, I guess, the back end of this application, shall we say. These are looks like it's like you'd use it for a robot's knee or elbow joint or something like that, right?
Yeah, okay. Exactly. This would be great for a robotic arm. And I feel like, I don't know if you feel this way, but actuator prices seem to have dropped a lot recently. And more and more people seem to want to build robotics. There's like a rush to build robotics with all the new AI vision capabilities.
Yep.
So it seems like actuators are kind of like one of those foundational pieces to enabling that. And I'm kind of wondering, what does the world start to look like with regard to actuators in the near future? To give a sense, okay, first of all, just breaking down an actuator, what do people care about, right? What's important on an actuator? There's torque, there's the size. A lot of people care about this gear mechanism. What's going on here?
So with the gearing mechanism specifically, there's a few important characteristics, but typically the one that you care most about in a lot of these applications, at least, is your ratio and your backlash. So ratio is obvious, and let's just lump that in with the torque of your design. So you care about its mass to torque and mass to power output ratios, right? Then specifically with backlash. So backlash is a characteristic if you've got a gear train and you've got just spur cut gears, like what you think of when you think of a gear. They'll have a bit of rattling between the teeth, right? And so if you transition from torquing in one way against a load to the other, all of a sudden, it'll whip backwards quickly, right?
Yeah.
And so if you're going for high precision movements, or if you grab a robot arm and you could rattle it, you would imagine that rattle would be, one, unsettling, and two, reduce your precision pretty significantly. And so both with harmonic drives, which are sort of the flex, the harmonic drives is a wobbling plate. And then there's the, what's the other type? There's a cup with a spline drive, basically.
Okay.
I think I'm getting them mixed up. Anyway, there's two types. You can either have these wobbling cycloidal drive, and a harmonic drive is a cup, and you kind of wobble it around inside. And those are zero backlash devices. They're always engaged, and they're always engaged tightly, or they can be made to be zero backlash. Gears, you can't. Just practically, you can't make zero backlash. So any typical planetary design is going to have some, and you can decide how much that matters.
Right. So there's all these kind of like mechanical aspects of the actuator, and it seems like people are getting better and better at making them. Does that mean that now we have kind of a software controller thing that people will start addressing? Because I don't know how standard that kind of stuff is, or if, I think a lot of companies right now are kind of building on a particular actuator that they're going to buy a lot of, probably, I would assume, because they all kind of have these slightly different properties, right? Is there a world where, are the actuators going to bundling controllers? Are there going to be standard actuator controllers? What do you think is going to happen if robotic arms and all of this stuff becomes more and more popular?
I think that... it's an interesting question. So the type of motor control that you're typically going to be doing in an actuator, you've got typically a brushless motor, right? And you're going to want to go beyond sort of quote unquote standard trapezoidal control because you need finer movements and higher torque and more precise responses. Right. So you're going to go to field-oriented control, which is just a fancy way of saying that you have better alignment between your magnets and where the electromagnet's trying to pull it to at the time, basically, and smooth the motion. Now, field-oriented control is mentally wacky, but exceedingly well documented. It's not hard for a company to implement. Hire an engineer, a quality engineer, get them to read the maths and write the software, and you can do it, right? It's not that hard. Now, then you go a layer back, and how do you actually want to talk to that algorithm now? You can apply torque, and you can add PID loops to make that down to speed and et cetera from there and position, and you can tune it. It's again a very known problem. PID loops are super standard. You can tune them.
This is one thing I'm really curious about is will people build controllers that kind of have the PID loops built into them, or is that always going to be external, controlled by the CPU, right? Because when I think about the daunting task of doing all of this and I see all the components, I'm like, man, wouldn't it be great if there was an actuator where I just gave it a position I'm kind of motor dumb here, but is that servos where you can give it the angle directly? Yeah. You basically want to give it the angle and say, get there as fast as possible or something like that.
Yeah. So I actually see that mentality and not having a better scheme of thinking about it as a big part of the problem, right?
The servo interface is not a good one if you're building complex arms.
No, because if you think a servo motor that you're thinking of the little rectangular hobby servos, right?
Yeah,
and they're for typically aircraft, hobby aircraft, and sometimes they make them for or planes and helicopters and RC cars as well. And they have subtly different control algorithms to them, but they're going for low precision. Backlash isn't a big deal because you've got continuous load against a flap, for example. They rattle, they're fine. They're not particularly precise. They don't actually tell the controller where they are. And all they're doing is getting to a position pretty much as fast as possible. As you say, that's what you think of. The problem with as fast as possible is with a sort of standard PID control, you end up basically always, if you're going from a 0 to a 1 step in position, and this is your time axis, you're always going to overshoot in the fastest ideal regime to get there quickly. If you undershoot, you're an underdamped system, you're going to get there to your position much more slowly, right? But is overshoot a good thing? What does does the profile along your path of motion actually matter while you're getting there? You know, if you've got an elbow joint or a shoulder joint and you quickly say go from 0 to 90 degrees, that robot arm would just whip around, right? Like you need much finer grain control.
Right. And then with that finer grain control, you also need to do calculations based on, I assume, like what your load is and stuff like that. So
if you want really precise control during that sort of motion path, then yeah, you have to do a lot of additional stuff to make that happen.
So basically, so taking it a level higher, will we see? I think maybe we already see this to an extent, but like you connect 3 actuators together and you're kind of telling it to do things, because now all the actuators can kind of work together a little bit more. But I guess like. For somebody completely new to actuators, never having worked with them, what does the software task look like when you're programming an arm, right? Like how much are you expecting to be taken care of for you today?
This is actually really a big part of the sell, I'd say, for every different actuator manufacturer. The hardware and the software, they're engineering problems, but they're straightforward.
Yeah.
The hardware and the control algorithms are straightforward. What interface you provide and how good library support you provide is something that, for example, would differentiate the O drive and its like pretty accessible Arduino libraries from Modius. You know, they have different set of C-based libraries that are great to communicate with and a different CAN protocol. And they all have different protocols to instruct it where to go and how to follow that profile. One might take and they have numerous different modes, right? So some of them just have a position mode and you do just tell it to go to a position as quick as possible. Another one, you can say, I want you to follow a trapezoidal profile and et cetera, but you've ended up encoding it in some kind of like very actuator specific, it could be genericized. They're not necessarily actuator specific, but because everyone implements their own like mechanism to describe the profile, you end up with that. Yeah.
Very interesting. What is that, by the way? A trapezoidal profile? What are we talking about here?
Well, you just sort of start at a position and then ramp to another position and stay there. Like ramp back down. Yeah.
Okay. I see.
Yeah.
Very interesting. Huh. Okay. Well, I was thinking Scientific. I think I want to say they're priced, these actuators are priced like between $200 and $1,000 for these big, I don't know what the torque is on this, but you've got some 5-pound weights at the end of a hand dumbbell. So pretty big actuators.
Yeah. I mean, as you said, 5 pounds. So you can easily enough curl 5 pounds yourself.
Yeah. But it's approximating a very weak human arm.
Yeah, that's good. I mean, it's a good place to start. The other interesting part of this question, right, is mechanical packaging. How do you stick what kind of off-the-shelf actuator would you want to generically stick it in your own arm, for example, your own robot leg? Like, is it going to fit where you want it to fit?
Yeah. That's a big thing too. There was there's so many different designs coming out for robots now. I saw, I don't know if you saw this video, but there was a robot in China that it turns out it was hard to put a pin in why the Tesla robot kind of walked weird.
Yep.
And somebody said it's because it's not locking its legs. Like its leg doesn't go fully extended and then it kind of like moves forward from that. It's impossible to like visualize that, but their legs are always kind of bent is like the way to think about it. And there was some robot company in China that did a demo where they did lock out the knee. And supposedly this is a more efficient, I mean, we do it for a reason, humans. So supposedly it's a more efficient method of travel, but my point being here, there are different, we still haven't nailed the perfect form. No. There's still innovation you can do there, or not really a standard, so you're not 100% sure which method to use.
We also have springiness, right? Like these are all stiff actuators that can emulate a spring, but they aren't themselves a spring, so you're going to be burning a lot more power doing that. And it's an interesting one.
Right.
What you do with like a series elastic actuator, for example.
Yeah, absolutely.
Wow, cool stuff.
Yes, very cool stuff. Matt, thanks for having me.
Thanks for coming, Seve.
Pleasure.